on to our next WOW video, which is part 284C3K33. And it's line 22f1fa19c3k33. Atoms, invisible Ligands, spheres, Gibbs mole, UFO 5G Wow Seti. There's a couple videos before this one that are all talking about Ligands, okay? So there's the alien radio signal, and here's a Cisplatin, PTLCl2 and H32, a platinum atom with 4 ligands. So we're talking about ligands still. This is a quote from Wiki. In chemistry, a coordination complex or metal complex is an atom or ion, usually metallic, bound to a surrounding array of molecules or anions that are in turn known as ligands or complexing agents. Many metal-containing compounds consist of coordination complexes. So here's another one here. Shows you the different designs that can make, right? CIS, COs, blah, 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 blah. The colored atoms form a coordinated sphere around the ion of cobalt. Now that's what you want. You wanted a sphere, right? In the middle of the core part of the spaceship. So obviously this has something to do with that. Quote from Wiki. In coordination chemistry, the coordination sphere refers to a central atom or ion, an array of molecules or anions. The ligands around. Molecules that are attached non-covalently to ligands are called the second coordination sphere. So August 14, 2012, I was working on the data. Today's November 20th, 2012 when I'm filming it. My thoughts. A center atom that floats connected by invisible ligands for the UFO engine design comes to mind. So I'm going to Google invisible ligands, see if they exist. This is what comes up. Structures of invisible excited protein states by relaxation dispersion. www.pnas.org. From P. Verpali, 2008. He talks about the ligand-bound form is invisible, and from a collection of those chemical shifts. Okay, that's on Google. Equilibrium fluctuations of a single folded protein reveal a multitude of whatever. www.pnas.org. Again, GR Bowman, 2012. This is brand new. It has previously been proposed that ligands bind cryptic sites via an induced fit mechanism because these sites are invisible and ligand-free. Another Google source. Thermodynamics. It is the energy, stupid. No, sorry, this is from someone's blog. So I'm not calling you stupid, okay? Thermodynamics is concerned with studying the exchange of energy within a given system. It could be argued that the emphasis on aesthetically pleasing 3D pictures of proteins over the past half-century or so may have distracted us from unraveling the invisible thermodynamic forces that drive protein-ligand interactions. The energy available to drive protein-ligand interactions, technically referred to as the free energy, so that little triangle guy there, it's got something to do with energy, is derived from the underlying enthalpic and entropic forces as embodied in the following Gibbs relationship. Glad you guys know what these symbols mean. Assuming that is less than 0 for protein-ligand interactions, 3 possible scenarios emerge as follows. And of course, I didn't write those down because you can go to his blog and see what they are. It's labs.med.miami.edu. Okay, Farouk research. So I'm going to Google Gibbs relationship to find out what it means. And quote from Wiki is Gibbs Duhem equation. In thermodynamics, the Gibbs Duhem equation describes the relationship between changes in chemical potential for components in a thermodynamical system. So here's the equation here. I'll make it a little bigger for you. Where Ni is the number of moles of component, I, DUI, probably can't see these little stinky numbers here, right? Oh, I don't know why they do this symbol stuff. Why don't they just stick it there so you can copy and paste it easier? The increment increase in chemical potential for this component, S, the entropy, T, the absolute temperature, V, volume, and P, the pressure. It shows that in thermodynamics, intensive properties are not independent but related, making it a mathematical statement of the state postulate. When pressure and temperature are variable only, I equal -1 of I. Components have independent values for chemical potential, and Gibbs phase rule follows. The law is named after Josiah Gibbs and Pierre Duhem. August 14, 2000. My thoughts. Looking at this equation, it reminds me of one of the alien formulas I got in line 17. T temperature, V volume, Ni. Li lithium plus, Google mole, so the mole unit. That's an SI base unit. Mole is a unit of measurement used in chemistry to express amounts of a chemical substance, defined as an amount of a substance that contains as many elementary entities, atoms, molecules, ions, electrons. As there are atoms in 12 grams of pure carbon-12, the isotope of carbon with atomic weight 12. This corresponds to a value of 6. Having trouble talking. I've got too much peanut butter in my mouth. Elementary entities of the substance. It is one of the base units in the International System of Units and has the unit symbol mole. The mole is widely used in chemistry instead of units of mass or volume as a convenient way to express the amounts of reactants and products of chemical reactions. For example, the chemical equation 2H2 plus O2 to 2H2O implies that 2 mole of dihydride and 1 mole of dioxygen react to form 2 mole of water. The mole may also be used to express the number of atoms, ions, or other elementary entities in some sample. The concentration of a solution is commonly expressed by its molarity, the number of moles of the dissolved substance per liter of solution. The number of molecules in a mole, known as Avogadro's number, is defined so that the mass of 1 mole of a substance, expressed in grams, is exactly equal to the substance's mean molecular weight. For example, the mean molecular weight of natural water is about 18.015, so 1 mole of water is about 18.015 grams. This property considerably simplifies many chemical and physical computations. The name gram molecule was formerly used for essentially the same concept. The name gram atom, abbreviated GAT, has been used for a related but distinct concept, namely quantity of a substance that contains Avogadro's number of atoms, whether isolated or combined in molecules. Thus, for example, 1 mole of MgB2 is 1 gram molecule of MgB2, but 3 gram atoms of MgB2. Gram atom Ligands. See next video. I'm going to Google it to find out what's going to bring up. Okay? Thanks for watching, and we'll go on to the next one.